Okay, so in the last video we looked at the nature of basically the square root principle, how to solve an equation that has a squared term in it. But now we're going to look at these in the form of trinomials, in the form of quadratic equations. We just talked about, we saw that that standard form was ax squared plus bx plus c equals 0. That's a quadratic equation in standard form. And some of these are going to be called perfect square trinomials. And that means that the quadratic equation can be expressed as the square of one binomial. So if you look at this equation right here, x squared minus 10x plus 25, this particular quadratic happens to be the same thing as the factors of it are x minus 5 times x minus 5, or x minus 5 squared. What we're going to do is we're going to use this concept to help us to solve some of these quadratics in a technique called completing the square. We'll see that on the next slide. But if you'll notice, the key thing about this in these particular perfect square trinomials, the c term, in this case it's 25, it happens to be the square of half of the b term. So the b is minus 10. What's half of minus 10? Minus 10 divided by 2 is equal to minus 5. What's minus 5 times minus 5? That equals 25, right? So the constant term, the c term, your c, is the square of 1/2 of the x term, or the first degree term, or the b term. So basically what you have is your c term is going to be equal to 1/2 of b squared in these perfect square trinomials. So the next step that we're going to do is called completing the square, and we're going to have a technique where we can take any old trinomial and turn it into a perfect square trinomial so that we can turn it into the square of a binomial, and then once we've got that, we can just take the square root of that binomial equals to whatever that is on the other side of the equation, and we end up with getting rid of that squared term. So we would end up with x minus 5 equals the square root of whatever was under there. We'll see that in a second. But understand that in a perfect square trinomial, the c term, the constant, is equal to 1/2 of the coefficient b squared. Okay, so in text, here's how this completing the square is going to work. We're going to basically get the coefficient of the x squared term by itself. So we want this to be 1x squared plus whatever bx plus c. So we want our a to equal 1. So we have to do general algebra rules to do that. Then we're going to rewrite this so that we have the constant c by itself on the right side. So we're going to turn this into x squared plus bx, that's an x, equals c. So this was basically equals 0 over here. Now we're going to move that c to the other side of the equation. Then we're going to do the completing the square technique, is we're going to take 1/2 of the b term, square it, and add it to both sides of the equation. So this would actually be x squared plus bx plus b over 2 squared equals c plus b over 2 squared. We're taking half of that b, squaring it, and adding it to both sides of the equation. Why? Well, because now this is a perfect square trinomial, and we can use that concept from the last page. Now we know that this is the same thing as x plus b over 2 squared equals c plus b over 2 squared. This you'll be able to calculate. Okay, and then now we can solve this by taking the square root of both sides. That's going to be a plus or minus on the right side, and this would be x plus your b over 2 equals plus or minus all of that stuff. And then you can simply solve for x. That's how we're going to use the completing the square technique. The main thing is you take half of that b, square it, add it to both sides, solve this as a perfect square trinomial. Let's look at it in action. So we're given 2x squared plus 8x, 2x squared equals 8x plus 90. First couple steps are to get this so that it's set up with the squared and the first degree term on the one side and the constant on the other. So first of all, we're going to divide that by 2 to get the coefficient of the x squared to be 1. And now we're going to move that 4x next to the x squared. So now we've got this in the proper format to now do completing the square. What's half of minus 4? half of minus 4 is minus 2, but you're adding, you're going to add this to both sides, but what's minus 2 squared? It's the same thing as 4. And you're adding minus 2 squared to this side, which is 4. So it happens to both sides. You end up with x squared minus 4x plus 4 equals 49. And this is the whole point. Now this is a perfect square trinomial, which is the same thing as half of this, b, x minus 2 squared equals 49. And now we just learned how to solve this equation. You take the square root of both sides. This would be plus or minus. And you end up with x minus 2 equals plus or minus the square root of 49, which is plus or minus 7. And then all you do is add 2 to both sides. And I don't like how they write that. I would write 2 plus or minus 7. What this means is that the solutions are 2 plus 7 and 2 minus 7 equals minus 5. Okay, so the solutions for this are x equals 9 or x equals minus 5. And I would like you to write this as a set notation from more negative to more positive as minus 5 and 9. Those are the two x numbers that satisfy this equation. We can look at one more really quickly. Again, we want to do a couple things to get this so that it's now in our format that we want. Now what we have to do is look at our b term of 7. We want to take half of that, which is 7 over 2, and square it and add that to both sides. It seems awkward at first, but doing this is going to get you to a good place. Now you know that this is a perfect squared trinomial, and all it is x plus 7/2 squared. And now you can do the simple math over here. This is actually, because it's a fraction, it's a little annoying, but 7 over 2 squared is 49 over 4. We want to add 8 to it, so we got to do some actual basic fraction math. So 49 fourths plus 8. We want to turn that into something over 4, which is 8 is the same thing as 32 over 4. And you end up with 81 over 4. And now we just take the square root of both sides. This, again, they're not putting that plus or minus in, but the plus or minus goes there. And now you see that x plus 7/2 is equal to plus or minus the square root of 81 over the square root of 4, which these happen to both be perfect squares, which is 9 over 2. So it's the same thing as, and now we're going to subtract 7/2 from both sides, minus 7 over 2, minus 7 over 2. And again, I would actually write this as x equals minus 7/2 plus or minus 9/2. So basically it's minus 3.5 plus 4.5, or minus 3.5 minus 4.5. If you do that, you end up with those two solutions. And again, I would write this as minus 8 and 1. But for our purposes, again, I'm okay if we leave it like this, because you did all the hard work. The rest is just reformatting it. Okay? Let's just do, I have 3 examples here. Let's just do one all together. So here, this is almost all set up the way we want it. It's in standard form now. I want to get this so that that constant is on the other side. So I want to subtract 5 from both sides, and I have x squared plus 6x equals minus 5. Now, this is ready. Now I want to take 1/2 of my b term, or 6 over 2. What is 6 over 2? Well, that's 3 in this case. So I'm going to take 3 squared and add it to both sides. So this is plus 6x plus 3 squared. I'm running out of space in my pen. 3 squared plus 9 equals minus 5 plus 9. I have to add that to both sides of the equation. Now this is a perfect square trinomial, which is the same thing as x plus 3 squared. That's the whole reason we did that. And if you're not sure, you can factor this out if you want, but that's going to be x plus 3 times x plus 3. You can check it by foiling. And then is equal to minus 5 plus 9 is going to equal to positive 4. Now I want to solve for x. We're going to use our square root property, which we worked on before. Take the square root I'm running out of space again. Square root of both sides, and that's going to be a plus or minus the square root of 4. X plus 3 equals plus or minus radical 4. X plus 3 equals, the square root of 4 is 2. This is plus or minus 2. We're going to take 3 away from both sides. We have x equals minus 3 plus or minus 2. Again, for me, good enough, but just so you know, that's the same thing as two solutions. X equals minus 3 plus 2, and x equals minus 3 minus 2 equals minus 1 equals minus 5. So our solution set here would be minus 5 minus 1. All right, and let's just do one more. This doesn't even have an equals. Let's say this is already set up as equals 0. Let's make this an actual equation. I want to get this so that it's the constant is on one side, so minus 32. You have minus 4m squared plus 8m equals minus 32. Now, I've got a constant in front of my m squared. I want to get rid of that. So I can actually, and this is going to work nice and evenly, but I can divide the entire equation by 4 to get that, actually by minus 4, to get that coefficient on the m to be a positive 1. So in this case, it's going to work out nicely. It's going to be m squared minus 2m equals, and minus 32 divided by minus 4 is positive 8. Okay, now I want to set this up so that I make this side a perfect square trinomial, which I need to take my b term of minus 2, take half of it, and square it. Again, I'm running out of my pen, and square it, which minus 2 over 2 is minus 1 squared. What's minus 1 times minus 1? It's going to equal 1. So what I do is I say m squared minus 2m plus 1 equals 8 plus 1. This is now a perfect square trinomial. This is the same thing as m minus 1. Remember, you're taking 1/2 of the b term. You're taking this. That is what's squared to get you this trinomial is equal to 8 plus 1 is 9. Again, last steps now. This should be hopefully be the easy part. Now we're taking the square root of both sides. That will be a plus or minus square root of 9. M minus 1 equals plus or minus square root of 9. M minus 1 equals plus or minus 3. M equals 1 plus or minus 3. And again, that's the same thing as 1 plus 3 and 1 minus 3. So it's going to be 4 or minus 2. I'm okay with this solution. I'm also okay with this solution. Make sense? Those mean the same thing. Okay, that's basically completing the square. You take whatever you're given, you rearrange it so you have the squared term and the x term on the left, the constant on the right, and you add 1/2 of the b term squared to both sides of the equation. That turns it into a perfect square trinomial. Then you can solve it by taking the square root of both sides and solving for the variable. That's the technique called completing the square. It's actually pretty useful once you practice it a bunch, and I will give you some practice problems for that. And next we'll pick up with something else called the quadratic formula.